Yeah. So the people that were vote.
All right. So, just to give you an idea, for the sake, and I'll go over this in a second, for the sake of this, I'm using BSD.
You know what I'm talking about.
It should, there it goes. A little bit of a lag.
Yeah.
So, the reason being, and I'll go over this real fast. So ZFS is, for those who don't know, ZFS was created by Sun Microsystems before the dark days of Oracle. What happened is they licensed their creations under Common Distribution and Development License, CDDL. They also call it the Sun license. That's what it's also nicknamed. It is a license that allows for open source collaboration, but it is not legally compatible with the GPL. So you run into an ideological problem where you cannot integrate ZFS in the mainline kernel. You can't. It's not legally. If you're Ubuntu and you tell Oracle, come at me, that's basically what they're doing. So
that
what
first letter, is that C or Z?
Z.
As in
Yeah.
zebra?
Yes.
Yep.
Z.
Okay, yeah.
They also call it ZFS. So the thing is that because the conflict of licensing, with the exception of Ubuntu, you have to build it as a DKMS driver, or you have to integrate it yourself.
Could you give a quick explanation on DKMS? I only learned about it recently.
So for those who don't know, DKMS is basically the pluggable driver module system for the Linux kernel. You hear about it mostly with video drivers, with like NVIDIA. DKMS is what allows you to say, oh, okay, I have my kernel. Oh, I need to integrate my video driver. So it builds a module and sticks it into the kernel. It allows as the name implies, it's called the dynamic kernel module system. So that's the way that you normally get ZFS to install into Linux, but it brings a whole other host of problems if you're running like Fedora, which runs along the main line, where all of a sudden it's supported, not supported. And if you update your kernel, you don't get ZFS anymore. It strips it out. So it's a pain. It's a pain that's getting better, but it's still a problem. So now if you're running something like CentOS or something, not a problem. They're so far behind on kernels that they actually build more for that stuff than they do for bleeding edge. For those who are thrifty enough, you can build your own modules from the source.
But you'll have to do it each time.
That's for another, yeah, and that's for another day. That's a fun topic. I've done that. But so now to flip it on the other side, the reason I'm using FreeBSD under the BSD 3 clause and 2 clause license, they are allowed to integrate ZFS. They don't have the problems that Linux has because the BSD license is compatible with the Sun license. They have at it. You can do whatever you want. So FreeBSD, since FreeBSD 8, if I remember correctly, has included ZFS. Not only that, it's built into the installer. So you don't have to do it by hand like you do on Linux. I can just go and set it up, and as you can see right here, ZFS. Oh, that's right, there's lag. I don't know why. There it goes. List. You have a second. I don't know why it's lagging, but there. That right there is the entire file tree, and I'll go over that in a second. That is the contents of the ZFS root. Z root is what it defaults to as its name. It's built in. It did all that for me when I ran the install CD.
So I'm gonna ask, since there's a root, does that mean that there's a client application?
I wouldn't know.
Just ask.
So, yes, yep. Well, they're BSD based, I think, more because it allows them to do commercial distribution. Under the FreeBSD license, you are allowed to use FreeBSD for profit. You can build a FreeBSD product.
Well, FreeBSD is free.
But they have commercial support. They have a commercial, there's a TrueNAS Enterprise, I think it's called. Yeah, where you get into where it's an appliance and they sell it to you and all that jazz. But yeah, if you just want to just do it yourself, self-hosted, they go, yeah, here you go, have fun. So we'll go back for a second here, but that's what it does. It builds all that out for you. So starting from the ground up, this here is a bone stock FreeBSD installed. Nothing is installed on it. The way you get started with ZFS is you have to define what's called a Z pool. A Z pool, there's two major utilities that build ZFS. A Z pool and then ZFS. Z pool is what you do with your disks. You have to define, disks have to be written with ZFS information on them in order to, kind of like MD, where you have to define them as part of this ecosystem, and then it fills in all the holes.
So it's sort of like when you do.
Yes, exactly. You have to define a pool. So by default, my pool is one drive called zroot also, because the pool name is also what the top most data set is called. So your top data set is root, basically, it's the root of ZFS. And then as you go down, you have the sub data sets.
Who's presenting? It's Ian.
It's Ian. I guess we'll, there you go.
Hello.
Question for you.
Sure.
Are ZFS and OpenZFS synonymous?
Now they are.
Now they are.
The only exception is Oracle still maintains their own branch of ZFS that's only available from Oracle, and that is vastly different. The ZFS that is now commonplace amongst the Linux ecosystems is OpenZFS. That it comes from upstream from something called the Lumos project, which is what became of Open Solaris, if anyone remembers
Oh,
that.
yeah,
The
yeah.
Lumos was
Oh,
what
yeah.
became of that whole mess. You can still actually download that as something called Open Indiana, which is about as close to Solaris as you're ever going to get without Oracle. So, but yeah, for all intended purposes, especially now, originally ZFS on Linux, it was called ZOL, and then you had OpenZFS on FreeBSD, ran parallel to each other. Not that long ago, I think it was like last year, they decided that the FreeBSD guys were going to drop their branch of ZFS that was coming from upstream and merge into ZFS on Linux, and then they decided to call the whole thing OpenZFS and get it over with. So now they are one and the same, and you can actually build a Z pool on FreeBSD and export it to Linux and vice versa. They do support each other because they're built on the same binary. Yes, and you can recover ZFS. So you could build a true NAS, technically speaking, and then export it over to Linux and read the data.
I got a dumb person question.
No such thing.
ZFS, it's a file system technology.
It's
like
a lot of
ESP64.
It is a lot of things. So at the baseler end of it, it is both a RAID, volume management.
So it's like LVM too.
Yes, it's also virtual disks. You can do what's called VDEVs, which are like QCOW things. And it also acts as a file system.
Yeah, but FreeNAS, by default, takes a RAID 10.
So in
Just I'll show you. Oh, half of it.
So in this case, what I can also do is I can do zpool stat. So zpool list just shows you all of the pools that are active. Zpool status shows you, give it a second, shows you what is the contents of the pool. So you can see here, because it's all written in FreeBSD dev speak, the pool is online, and its configuration is made up of one disk. The pool's named zroot, and the disk that makes up that pool is DA0 partition 3. So what we're going to do is I have also included a couple more drives in the machine here, virtual disks. So I put another 2 drives in here, DA1 and DA2. And these would be the equivalent, for those who don't know the FreeBSD modeling, that's the equivalent of dev SDA, dev SDB, stuff like that. They use different terminology. So what we're going to do is we're going to make a Z pool. So there are a myriad of commands, or not commands, but a myriad of what they call properties that you can set and unset, and things which will change the behavior. So this is just a list of them. As you can see, you have Some of them are what they call, what's the word in programming? Immutable. Yeah, you can't change them once they've been changed. So things like size, capacity, those ones, they can't be altered once they've been created.
Okay.
But if you notice, you have things like auto expand, dedupe ratio. Deduplication is something really crazy, but unless you need it, you should never enable it because it is a RAM hog. It takes about 10 gigs of RAM per terabyte of storage or something. What deduplication is on a nutshell is, let's say you have a file and at the block level, because everything here is blocks and partitions. We're not talking about, files. Let's say you got the same copy of the file and it's made of four storage blocks. 3 of those storage blocks are duplicates across each file. So what ZFS will do if you have dedupe, which stands for deduplication, it will only store 1 copy of that block, and then it will put pointers to that block for the other 3 copies, effectively reducing it by 75%.
But you're trading RAM.
But what you have to do is you have to build a deduplication pointer table in RAM, which the more data you store, the bigger it expands. The problem is kind of like the problem with virtualization. If you do not have a way for the system to know what to do if it runs out of RAM, ZFS will crash. It runs straight into a brick wall. You run out of RAM, the whole thing just comes down. And then you can't disable dedupe once you've enabled. Even though you have the option to turn it off, it never really turns off. It just kind of gets stuck. It's weird. So they tell people, unless you know what you're doing and you know you need that feature, leave it off. It's not worth it because you can do compression. You can do compression algorithms. You can do other things to squeeze more space out of it. Everyone thinks, oh, dedupe, and then they run into the problem of it ends up needing 60 gigs of RAM, and they go, I didn't know I needed it.
What is delegation?
Delegation. That one, I'm not honestly sure. Some of these I'm not really familiar with. Auto expand is neat. Auto expand allows you to set like rules where, and that one's mostly for not. Some of these are for pool only, and others are for data sets. Some of the flags. And what you can have is like auto expand allows you to set up a drive and say, okay, if I start filling up these drives, move on to the next drive. Give me, and you can set hot spares, cold spares, things like that. So, but yeah, like you have auto trim. Auto trim is trim from SSDs. The thing can set up trim to keep itself clean. The ones you see here, the features and stuff, that has to do with what the bootloader and stuff will support. Like Grub out of default only supports like 5 features of ZFS, but it doesn't matter because it's Grub. Like you just tell Grub, yeah, do what you need to do, and then you tell your root partition, oh, you got all the cool features. So the big one that ZFS brings to the table, and you ever heard, who heard of what bitrot is? Bitrot, bitrot.
Basically, data loss based on.
Yeah, it's the creeping corruption. It's like rust for a computer. So ZFS claims that it's bitrot proof, basically. What it does is occasionally ZFS will do something called scrubbing, where, because ZFS is also what they call a checksumming file system. Every block of data that gets written to ZFS gets a SHA-256 checksum associated with it. What it does is occasionally the machine will do a scrub. What a scrub is it walks over the blocks and it compares them to the checksums. And if the checksums don't match, it attempts to correct the data, almost like ECC, and attempts to parity the data. And if it can't, it'll kick the block. It'll try to recover it, or from like another backup sector or something. But it basically fluffs up the data every once in a while to go, okay, everything's still good. Yeah, we're good. And then if it doesn't, finds problems, it remedies those problems. Yeah, well, ZFS also does caching and other things too that make it really crazy. you have what's called the ARC cache, which is the read cache, adaptive read cache. So if all of a sudden ZFS starts seeing, man, you're pulling a lot of files from this location, what it does is it puts that into RAM. And it holds those blocks in RAM, knowing that you're going to want a lot of data from it, instead of having to constantly call it off the disk. And then on the flip side, you have what's called ZIL, Z-I-L, the ZFS intent log. ZFS intent log is anyone familiar with RAID cards with batteries? When that used to be the thing, the battery backups, the flash RAM on them, on like a RAID card.
Yeah.
Oh, yeah.
That was the same idea. It was a temporary cache that was really fast, and it could keep up as the hard drives were slow. The RAID card would go, yeah, I got it, yeah, I got it, yeah, I got it, and it would put it on this RAM, and then tell the computer, yeah, go on with your duties, and then in 3 seconds it would flush the buffer to the hard drives. ZFS can do the same thing. You can put a crazy fast SSD or a RAM disk, like one of those cards with the RAM on them, and then tell ZFS, that is a really stupid fast disk. I want you to put all of your writes on that disk. And then every 5 seconds, it flushes it off to the hard drives. So it allows you to use spinning Rust 16 terabyte, drives, instead of having to buy a fortune in SSDs. But you can have this thing respond with the speed of an NVMe drive. So, and the only case, of course, is it's going to beat the drive up. So they recommend for that you use a drive with a high wear cycle, like a single level SSD or something, something that can take the beating, of being written to. Now those are only for synchronized writes. If you're doing async writes, which is what 99% of computer writes are to hard drives, you actually bypass the cache. So it's always going to be slow. Now, what you do in that case is you remount your root partition under sync, and for like FS tab and stuff, you tell it to do sync writes for everything, which you would think normally would make everything very, very, very slow. But because ZFS puts it on a piece of flash memory, it responds, crazy fast. So it's
Flash drive craps out.
in that case, actually, because the drive is not explicitly linked to the RAID, it'll just degrade the flash. It'll flag. If you look at the
It goes straight to the RAID.
no, what it will do is if you look back here, the under the status, what it will do is you'll have a separate, and I'll show this in a second here, you have a separate thing that'll say log, slog, and it'll just, instead of online, it'll say degrade. So then you would just say, oh, I need to replace this, ZFS replace, give it the new disk, and it pretends like nothing ever happened. Yeah. So, all right, so we're gonna go ahead and make I'm going to clear the screen here. We're gonna go ahead and make a ZFS. So this is the basics. The reason I've shown the properties is I'm not gonna go into all of this. There's documentation, and every one of them is, your mileage may vary. Some of them you need, others are special uses, stuff like that. But I'm just gonna do the most bare bones thing here. So we're gonna make a mirror. So it's zpool create, and then you have to give it a name. So I'll call this one ALUG zpool. And then in this case, because we're doing a mirror, I have to define mirror as my keyword. And then here we do /dev DA1 /dev DA2, because those are my two mirror drives. I'm pretty sure I got this right. And there we go. See you in a second. That's it. The RAID is we just made a zpool RAID. So now if I do zpool list, you will see we now have another pool, ALUG zpool. And then as you can see, it is 19 gigs. Those were each 20 gigabyte things, but because I mirrored them, n minus n minus, or 1 minus n, or what is it? N minus, n divided by 2. That's what it is. So it's your entire space cut in half. So in this case, it's still 20 gigs. But now if I do zpool status, ALUG Z pool, you can see, second, we now have 2 disks in a mirror under that pool. The reason it calls it mirror 0 is that I can define multiple mirrors. I can actually, so normally when you think of a RAID, like mirrors and stuff, you're one dimensional. I can actually take and make another mirror inside of that pool. Or I could even say, you know what, I want one pool and I want one RAID 5. And then and you can do n-way mirroring. So I could do 2, 3 mirrors and then have them all mirror each other, or do RAID 5 on each other. So you can do all these clever configurations of things. But the reason you can also do that is for what they call Z-pool expansion, which is a feature that's on its way in the new versions, where let's say I've only got 20 gigs. 20 gigs is nothing. I could download files that'll blow that out. Well, what do I do when I can't rebuild the RAID? Because if I rebuild the RAID, I'm going to destroy the RAID. Yeah. So what I can do is I can just add another mirror, and then it'll just say, okay, it's another mirror, but it's all under the same pool called ALUG Z pool. So the disk.
Could I make that mirror larger and therefore start like
the next one you could, but now they are working on a feature where you could do an online expansion of a current RAID. So you could convert it, but that does not work yet. That's on the way. That's in the next couple versions. As of right now, you could just do mirror 0, mirror 1, mirror 2, 3, 4, 5, or RAID. ZFS doesn't do RAID 5. It does what's called RAID Z. The difference between RAID 5 and RAID Z is that, I don't know this, and maybe someone else, I don't know if you're familiar with this, it's called the RAID 5 write hole. It's a problem where you have a power loss and the intent data that hasn't been written to the disk is still kind of like in the journal almost. And it causes some kind of problem with synchronization. I'm not 100% sure, but it's a problem that affects Better FS right now, or Butter FS as they call it. That's why they don't have RAID 5 and RAID 6. It's this weird inconsistency problem. ZFS got around it through the ZFS intent law. That's how they got around it, is by, yeah.
I'm sorry, but
You're good.
before you made that A-log here,
Yes.
was your Z root originally about 50 gigs of OFA?
No, Z-root is an entirely different hardware. That's the one that the OS is installing.
Okay,
The one that I made is a secondary storage, for example.
so you're making these reads on one hard drive?
The normal one, the one called Z-root, that's 40 gig, that is a separate hard drive.
By
Just
itself.
one. It's one drive in a stripe, and that's all it is. The other 2, DA1 and DA2, those ones got mirrored together and then became ALUG-Z.
Okay. I understand that. But your root then is 2 drives and a mirror.
No, and I'll show you that. I'll show that in a second.
The way you keep explaining, it sounds like a 4-1 drive involved. That's what's on it.
Okay. Well, let me show you.
Like in terms of physical drives themselves, like, it would be helpful to know, like, let's say when you're starting out, how many drives did you start out with?
They're in the
And then
VM.
Using them, how many pools are created, which have,
Okay.
like that.
have a quick drawing?
That kind of divide.
Yeah, I see what you're getting at.
I guess you could call it a progression, because you're planning for it, right? Like you're.
Yes. Yeah. Well, let me show you
All
this.
you have is one drive.
So let me show you this for just to show this off. So I don't know why this thing's lagging, but so if you can see, it's really small, but you can see here that there is one hard drive, SCSI. They're all SCSI emulated. But then there's disk 2 and disk 3. So the one drive is what I installed FreeBSD on, and then the other 2 were just stuffed in there to give me something to make a read out.
All right.
Yeah.
So you had.
Now,
two
the answer to your question though about is it rude and what and what is what and everything, that kind of is an interesting question, and I'll show you here why. So when you initialize everything into ZFS, you get back to this, which will, the data set list. So, okay, so we made the pool. The pool is the RAID. The pool is also, though, the topmost level of the ZFS. So as you can see at the very tip top there, you have ALUGZ. Now that on its own is both a RAID and a director. I can write to that folder, that mount point. I can write files on that. I don't need all of those extra folders.
Does it automatically do that? Like,
Yes,
when you create that,
unless
don't have to add
you-
an FS tab or-
Well, if,
Well, open the FS tab and show them.
well, that's the thing, FS tab is not part of this.
Okay, oh. So that's-
FS tab is only part of this if you enable the flag, which is called mount point legacy. By default, ZFS auto mounts. It has its own mount point generator built in. So if you tell it, and here's one of the things, so under, so let me show you this. This is one of the properties that matters. So, what is it called? Can mount. ZFS can mount 0. So what can mount is exactly as the question it asks. Can that data set be mounted?
Oh,
And the answer is, right now, is set to on. On being the feature is enabled, it's called a property. However, you can also have other ones like the one below it, and this is also how you reference things. So let's say I want to look at the one that's root in capital letters. So I reference it like a file, zroot / root in capital letters. Now you'll notice that one also says can mount on. I'm trying to remember, I think it's the one below it, default. One of them, yeah, there it is. So what you'll see here, you see how the first one says on, the second one says on, but the third one, which is default, which is where it stores the kernel as it is right now, basically the OS. As you can see, it says no auto. What no auto means is that's what you're talking about with FS tab. What we're saying is you can mount all that stuff, but that one, no, you leave that to FreeBSD. You let FreeBSD handle its own root. And then that's where, like you were asking about,
That's how they deal with the problem, because that's what LVM, off by one stuff for who.
actually, it's funny because it's not even in here, the FS tab. But that's basically the idea, is that no auto says when you boot, because what happens is when you import a Z boot, unless you tell it a certain flag, which I believe it's -N, it will mount all of the file system. So there's sometimes where you're doing debugging or something where you don't want it to load your home and your root, or not your root, but your /root or games and var and log. You just wanted to get just the bare bones so you can figure out what broke.
Yeah.
And that's what you do. You say, don't mount anything, I'll mount it manually. And that's how you get around that, is you say no auto. So no auto means we're not going to mount this automatically, we're going to do it after something. Or in this case, the bootloader would take care of it. So, but going back to the data sets, so as you can see, we have so we have all the zroot stuff, which is just the system files, temp, USR, home, ports, source, var, all your usual suspects.
Right.
So let's say that we want to use our new Z pool and we want to do something. We'll call it, we'll make like a music and documents and stuff like that. So we can define subset, what they call data sets. Data sets are done the same way you do a Z pool. You do create, except the difference is we're not using Z pool, we're using ZFS. Those are the two main tools. So we do ZFS create, and then you have to define kind of like a fully qualified path. You have to start from the top. So in this case, our top is going to be the name ALUG Z pool. So, and then let's say, I don't know, what do we want to make? Let's make a folder for Rick. So we now have a folder in there called Rick. So if I refresh by doing another list, you'll see that now we have still catching up. We have ALUG Z pool. Then we have a sub data set for Rick. So now if I want to add another pool, another data set to that called, say, music, I hit up because history is great. And now we now have a tree starting to form. So there you go. Now, if you can see on the right side, you can see the mount point. So the mount point that automatically got generated was on root ALUGZ. Inside of that is inside of that with inside of that. So that's your, I can do this. I can do ALUG underscore Z. And you can see there's Rick, and then inside of Rick is music. So there you go. That's how you automatically do that.
So all of these are sharing the same storage, that way, that's why they all.
It's a parent-child relationship. So ALUG Z pool is the RAID and the root of that Z pool. Then inside of that, we made basically subdirectories.
That's why they all share the same available space.
Yes, that too.
Reefer means
Reefer, that I don't honestly know. It has something to do, I think, with I think it has to do with the amount of space that's actually been allocated for that pointer. Because what it'll have is sometimes if you start to fill up one of them, as you can see, they have different space uses. Like var log has 164K, the other one has 546 meg. It's basically the amount of space inside the pool that particular data set is eating up. So now one problem you may see with this is that under our defaults, what if you didn't want those files to be under ALUG Z pool, just like all of the system files? You want them over here, but maybe you have that one file, you go, man, I really wish that this would mount up at a different place. You can alter those mount points on the individual data sets. So I can take.
That's why you would create this. Okay.
So what I can do is I can make another folder called, I don't know, whatever, I'll figure something. I'll call it, I'll do jails because FreeBSD and jails. So what I can do is under ALUG Z pool, I forgot, I got to put a flag. This is where the flags come in. So you usually use the O option. And then you would do mount point, in this case, equals. And then let's say I want to mount this up to USR home E, just because. And we're going to put it, we're going to put it there. And then we're going to call this fun stuff. I don't know what to name it. So what we have now done is we have changed as you can see, the second line from the top. ALUG Z pool / fun stuff is mounted to my home folder. The home folder that FreeBSD assigned.
So it's now replacing.
Yes. Now what's neat about that is anything that comes after that, however, so let's do another folder in there called super fun stuff. What happens now is because the root mount, or not the root, the parent of that folder, fun stuff, was my mount point. Now, what you end up with is everything under it inherits the mount point. Now, unfortunately, that can also create some problems on occasion, as you can see, because now it's actually double mounted that folder underneath. So you got to be careful how you word things because it gets weird. And that's the nature of it's like a lot of things in Linux. It's very verbose. It's written on the idea that you know what you're doing. And there's documentation that the man pages for CFS are exceptional. They go into vast detail. So I highly recommend, looking at their documentation. If you want to understand things, you can, and the nice part is you can even look at the man pages and it'll explain all of the flags. Oh, you want to know what compression is? Compression means this. These are your options. These are what we support. This is what we do not support. You can do this, but if you do this, you can't do this. Da 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 da. It goes over all those things. You know, so you have a lot of options. The really cool thing about CFS I forgot to mention is it's a snapshotting file system. So you run into a problem. I'm going to be doing, say, a system upgrade. Okay, well, there is a chance, while slim, that I am going to destroy my system. You can make clone snapshots of your files. So let's say, for example, I'm going to put a file in. Actually, no, I'll use. I don't have Vim on here. Vim's my favorite. So no, no, maybe it does. I use Edit, the graphical editor. It works just okay. So let's say we're going to put something in. Let's see. I'll put it in ALUGZ pool Rick because the other one's all screwed up. So, oh no, that's wrong because it's a directory. We'll call this just test.txt. And in here we're going to put, I don't know, Linux is awesome. Whatever. Doesn't matter what it is. All right. So what we're going to do now is I'm going to do a snapshot.
Yeah, that's look like what's.
Does? I wouldn't know. I'll take your guys' word for it. So what I've done is I've made a folder I've made a document in that folder, ALUG pool Rick. Okay, and we can look at it. Yeah, and we can see right there, test, no, a second. Test.txt. Okay, and we know what the file had in, right? So now what I can do is I can do a snapshot, ZFS snapshot, and you have to do it the same way. You have to define it by its pool name, not its mount point name. So you have to look to the left column, ALUG, and a lot of this it's all absolute path. So you can't. There's no dots and shortcuts and tildes. You have to give it the whole name. Now there is bash completion, so someone at least had the good sense to.
Are you in bash? I thought it was
No,
C shell.
no, this is C shell, but there is bash completion and C shell completion, and a lot of the other ones have completion scripts, which is nice because even this gets old after a while. So what we can do though is I can snapshot the RIC file, and then what you do is you give it the name of what you wanted to call it, then you put an @ symbol. And then you give it a name, a snapshot. So in this case, we'll call it docs backup. So what I've done is I've snapshotted that thing. So what we can do now is the snapshots, I'll show you. That's what I was going to show right here. Sorry. So it should be -T snapshot. Yes. So what I've done is I'm filtering with the T. T is a type. So I'm saying, show me the type, show me the ZFS list, but only show me snapshots. As you can see, I have a snapshot called docs backup. It's not mounted to anything because I'm not using it. It's kind of floating off on its own. But to show you where it stores them just like LVM and stuff. It would store them in the tree, but they're not mounted to anything. So it just kind of leaves them off on their own. That's why you have to show them with that type flag. So there is a way to do it. I just can't remember how to show it in the main tree. So now what happens is, let's say I want to go back to that file, the edit file that we made. And now I want to say, somebody's trolling my server. So now I was going to say, Linux isn't awesome. Depending on the day, they might be right. So now, okay, shoot, what am I gonna do? I gotta figure out, I gotta fix my stuff. Someone's trashed my server. CFS, rollback. And then it's ALUG, cpool, RIC, @ docs And it is important that you get this, get your names right, because it does matter. All right, I just rolled it back. Now, if I go back to that file. Second. File is back to the way it was. So you can do more than just single, well, you can only do data sets. So you cannot zero in on a file. You can't do that with ZFS. It's looking at it at the bucket, basically. You want everything in this pseudo directory to be rolled back. So something like, say, a website, you would make a sub data set for awesomestuff.com. And then you would say, oh, someone broke that website, roll it back, and it's like it never happened. And you can do snapshots of snapshots. You can take snapshots and you can do a feature for another day called ZFS get and ZFS send, where you can actually move it across the network to another ZFS server.
Ooh, replication.
Yeah, and you can also do tar. You can push it to a tarball, so you can take a ZFS send and then get it with tar, and then gzip it and the whole bit. Or not tar, just gz, because it's a ZFS partition. So you have to then basically re-inject it into ZFS. But it allows you to take the whole thing and say, oh, I want to store this elsewhere. And you can also, and ZFS does support encryption too. It supports both cert encryption and password based. But that, for the lack of a better way, that's the nutshell. That's the nutshells of ZFS.
So this file that you wrote,
Mhm.
the docs file,
Yes.
on your DA1 and DA2,
Mhm.
if let's say you were inspecting the contents of DA1 and DA2, would you be able to find them in both of them, like both like physical drives or like?
Well, it is a mirror, so yes.
So you,
Mhm.
so, okay, cool.
Yeah, if DA1 went offline.
Yeah. So
Um, Yeah, because a mirror drive is a duplicate. They are a one-to-one binary copy. On the other hand, if, like, for example, Stripe, if you lose part of your Stripe as a RAID 0, you lose all of it. Yeah.
Really? Okay.
Yes, RAID 0. I always like to remember this. It's a little rule of thumb. RAID 0 has 0 redundancy.
Okay. Yeah, that's true.
Yeah.
And if you think about it, RAID 1 has 1 redundancy. RAID 5 gets into weird because it's technically 1 redundancy, but whatever, we're not gonna get into that.
Yeah.
So, yeah, so that's really ZFS in a nutshell. Did anyone have any additional things anything they want to know?
Appreciate you doing that, but now I understand what you mean. I'm sitting there blindly going through
Yeah.
Linux stuff isn't working. What the hell?
Yeah.
So hypothetically, I don't want you to like do this, but
Sure.
basically just talk it through. So right now, what you have, let's say, one of the drives like gets offline, whatever,
Mhm.
just kind of have it anymore. And you actually edited the same file in the store.
Yes.
When that drive DA1 comes back online, does ZFS reconcile like the contents of the file? Like how does it?
Well, you're thinking too low level.
Yeah. Well,
So ZFS is working in blocks.
Okay.
Okay, blocks are the combination of sectors, heads, cylinder sectors and heads.
Okay.
Basically the mapping. It's a map on the hard drive. ZFS is literally in a mirror. It's saying, you want me to write something? I'm going to duplicate it. Boom, boom.
I had a drive go out.
Mhm.
And I had to replace. But I had to rebuild it.
Yes, it does have to rebuild it.
They rebuilt
Because
Okay.
the reason it rebuilds it is because it doesn't know if the data is intact. ZFS is built on what they call it a zero trust model. If I remember, it assumes the disk is lying. So it says, "Oh, you're alive." No, you're not. And it assumes if the drive hits a bump, it just fails it and says, because it's built on the highest level of redundancy possible. Well, the highest level of redundancy possible means that you have to assume that the physical media is the defect. If you,
Yeah.
so ZFS is very skeptical And that's why you have things like the checksumming and the scrubbing where it goes, I don't believe, I'm gonna double check your
What you're
checksums.
saying, right?
Uh-huh,
Also, this scenario I just mentioned, so for example, DA2 is active, DA1 is not. You know,
there we go.
you make a change in DA2.
There we go.
the file,
That's what I was doing right there.
Yeah.
So I just went and just pulled that
DA1.
disk. Yeah, I just pulled that disk offline. So as you saw, FreeBSD went, whoa, what'd you do?
DA2 is not.
Yes, so what I'm gonna do now is I'm gonna show you ZFS status ALUG. And what you can see is, a second, degraded.
Oh,
So now I got a problem because, yeah, I'm still running because it's a mirror and it's also an artificial crash. So
Yeah.
you don't know if the other drive is on its last leg too. So what'll happen is, yeah, now you can see though, if I go into that folder,
right, if you were to edit your file again.
the file's still there.
Yep.
Yeah, so I can go,
Service from DA1.
yes, yes, because if you notice DA1 says it's online. So in the case of a mirror, we've lost half of our redundancy, but we're still running.
Operation.
Yeah, on a RAID 5 array, the 3 disks together, you lose one, you're there, but man, you better be getting another disk ready because you lose the other one, you are boned.
So
You
now,
got nothing.
now edit the file.
Sure.
So like you did before.
Mhm.
So make it like. One tool also. Okay, BSD.
All right. So now, yeah, and as far as ZFS is concerned, ZFS,
That
the,
file is there.
yeah, the file is still intact.
Right.
Or not the files, the file system is still intact. The difference is we've just lost our redundancy.
Correct.
So the way, of course, now would be, just like any RAID, you would say, okay, what happened?
Yeah.
So what I could show you, but I'm not going to, but what you can do is you do what's called zpool replace. So you insert the new drive, you get its identifier, and then you tell the ZFS pool, I want you to swap this disk for that disk. And it goes ahead and it does that, and then because it's a mirror or a RAID 5 is the same way, it has to rebuild. It has to recalculate.
Is there a journal? Is it?
The journal, yes,
Playback been changed.
there is, that's the intent log. The intent log, and then with
Oh, right,
another,
still.
yeah, and then there's another component of it called ZDB, the ZFS database, which is a tool you can actually, and this is way beyond my understanding, you can actually use the tools almost like in a forensics way to pick through the commit logs of ZIL with ZDB and actually pull out data, like fingerprints of data, and recover things that have been corrupted. You can do some crazy stuff. That's what's the one guy, level 1 techs, Wendell. He does a video on how to recover data from a busted ZFS array. It is very in depth.
Okay.
But it is one of those things where if you cannot, this data, I must have this data.
Right. It's like,
Yeah. Oh, well, and the other thing too is anyone who's ever worked with snapshots, they warn you with ZFS, snapshots are not backups. They are the start of a backup, but they themselves are not backups. Now, once you could export that snapshot with the ZFS send, ZFS receive, and yeah, once you do that, yeah, now you have a backup. But just snapshotting it, that ain't a backup because you're still on the same disk array that, as we can see, just failed. Mhm. And of course, I'm on Discord if anyone has any additional questions. I feel like sometimes that's the better way rather than climbing the mountain. So, but did anyone have any additional questions?
Very good.
For being something that I came up with off the top of my head
Yeah.
yesterday, I think I did okay.
Yeah, that's very
You
good.
also had like, you knew you wanted to present this.
Oh,
so
yeah.
you just kind of.
Yeah.
Through the stuff you already
Yeah.
know, and this was a good way to. Perfect.
So you're already using this.
Thank you. Well, I've got TrueNAS.
Yeah, freenas/TrueNAS is a great way.
Through it,
that is an excellent way for anyone who wants to get started with CFS but doesn't want to go the terminal route. You can use, they have an excellent web interface that does all the nitty gritty for you.
What was that?
TrueNets, FreeNets, TrueNets.